All right, last but not least, we need to talk about solving a matrix equation. Okay, so when two matrices are equal to each other, they're going to have the same dimensions, because otherwise it's impossible to be equal. And if two matrices are equal to each other, then again, corresponding elements should be equal. So whatever's in the first row, first column in one should equal what's in the first row, first column in the other. So you can see in this example that, there's 6 and the 6 are in the same spot, and the 5 and the 5. Okay, they're equal to each other, which means we can solve for x and y by using this concept. Because x plus 8 and 14 minus x, they're in the same exact locations, just in two separate matrices. And since the matrices are equal, x plus 8 must equal 14 minus x. And because the same thing is going to be true with our y's. If you look in the very last spot, the third row, second column in each matrix, because these matrices are equal, 2y minus 1 is going to equal negative 13 minus y. Now you can solve for your variables by just solving these two tiny equations. So let's look over at the x one. Well, in order to solve any equation, you want your variables on one side and everything else on the other. So we're going to start by adding this x to both sides and moving this 8 over by subtraction. So when you add x, you get 2x. When you subtract the 8 from 14, you get 6. Then you're going to divide both sides by 2, and x equals 3. We're going to do the same thing over here. But we're going to start by adding y to both sides and adding 1 to both sides to get all the y's on the left and everything else on the right. And when you do that, you end up with 3y equals negative 12. Then we need to get rid of the 3, so we're going to divide both sides by 3, and y is negative 4. So there are your answers. X equals 3, and y equals negative 4. And you can always check this, because when you plug 3 into your x plus 8 and your 14 minus x, you should get the same number, which we do, it's 11. And when you plug negative 4 into both numbers, or in both places for y, you should get negative 9. And you do. So let's look at this one. This one's a little more complicated because there's more steps. Okay? So you've got 2 times the addition of two matrices equals another matrix. Well, in order to solve this, you want it to be one matrix equals another. So that really complicated side on the left, you want to group together and you want to simplify it so you do only have one matrix. Okay? And when you simplify and do all that stuff to the left side, just remember your order of operations. And the first thing we're going to start with is what's in the parentheses. Okay? And with what's in the parentheses, we're adding. The matrices are the same dimension, so we know it works. So we're just going to add them together. Okay? So step 1 is to simplify, and we're going to take that complicated left side, and we're going to start inside our parentheses by adding our two matrices. So when we do that, you get 3x plus 4. We're taking negative 1 and adding 1. 8 and adding negative 2. And 5 and adding negative y. Then the right side's staying the same. We're not touching it. We're just rewriting it. And then the matrix that we have combined, we're going to multiply it by 2. So you can really simplify this matrix a little bit more by combining like terms in our negative 1 plus 1 and our 8 minus 2. So let's go ahead and take care of that. And that leaves us with a 0 and a 6 in those spots. Now we can do our scalar multiplication. Okay, we can multiply everything by 2. Now remember, when you multiply the 3x plus 4 and the 5 minus y by 2, you have to actually distribute the 2 to both terms. So 2 times 3x plus 4 turns into 6x plus 8. 2 times 0 is 0. 2 times 6 is 12. And 2 times 5 minus y is where you've got to distribute again. And so that's going to be 10 minus 2y. So we took that really ugly, complicated thing on the left, and we added our matrices together. We did our scalar multiplication, just following order of operations, and that's left us with a matrix equal to a matrix. So now it's really easy, because we know that 6x plus 8 has to equal 26, and 10 minus 2y must equal 8. So just separate those equations individually and work them out with basic algebra. So the 6x plus 8 must equal 26, and the 10 minus 2y must equal 8. So 6x plus 8 equals 26. You want to subtract your 8. So that's 6x equals 18. Divide your 6, and x equals 3. Pardon me. Same thing with the 10 minus 2y equals 8, except we're going to start by subtracting 10. So you get negative 2y equals negative 10. And then you want to divide by negative 2, so y equals 1. Pardon me. All right. And that pretty much sums us up with these two solutions. So this would be the answer to that entire messy matrix equation we started with a few slides ago. All right. So hopefully this has all made sense. We've broken it up into 3 videos. We should be able to find our dimensions, know the address of every element, add matrices, subtract matrices, scalar multiplication, and solving matrix equations. So that was our goal. So now you can take these videos and rewatch them if you need to. Take your notes that you should have filled in and hopefully taken some extra notes along the way on, and use that to help you do your worksheet. I'll be going over the worksheet with you tomorrow, and we're going to go into matrix multiplication then. So hopefully we all had a great day, and I am looking forward to seeing all of your smiling, wonderful faces when I come back tomorrow. All right. Have a great day, guys. Bye.